walk through to give an idea. But also, I don't know how much you want to talk about the background of the actual project. Obviously, Alex knows it in a lot of detail. I'm not sure about Francesca and Alan. And yeah, I don't really know to what extent people are picking this up, or it's more just to be sure that, like, generally we're aware that this exists or what.
Okay, I'll say a little bit and so give them a little bit background.
Okay.
We developed this model using this LiDAR waveform. I think Francesca trying like look at some of the JEDI data. JEDI gave you the full waveform means like continue return worthfully. And so Alex basically converted my IDL code into Python, and then Ian is trying to make it like easier, build some kind of uh, I don't know, interface so that you could run it easily. Oh, he did a bunch of other stuff like fine tune or whatever the algorithm. But I think he developed this too so that people like I don't know, no background can still run it. So
Probably
that's
not no background, but a little less background. Yeah. Yeah.
so someone like not so technically like
Yeah.
whatever
Yeah.
could still run it, right? And because we are using JEDI with the spaceborne LiDAR, I know Alan worked on a lot of LiDAR data that's more airborne and more like point cloud data. It's not waveform. And Alan has this enough background, so we kind of beam this point cloud into pseudo waveform, this continual
Oh, interesting.
return.
Yeah. Yeah.
Yeah, so Alan should be fine. Yeah. So anyway, because of this, we're processing this global data. My final goal is we want to run our model globally, produce global biomass
Yeah.
map. Okay. So of course there's a lot of issues because JEDI is just like a sampling mission means like they're not sampling everywhere, not like a raster data. So there's a lot of gaps in the map. So but anyway, I really want to get this model run globally. I think Ian probably made it possible now.
Yeah. Yeah. I
Um,
can maybe I can jump in because that's a good intro to like explaining some of the motivation for what I did. Or is
yeah.
there more you wanted to say?
No, that's it. I think that's it.
Okay.
Yeah.
Okay. Also, hi, Alan. Sorry, I said hi to Alex
Hey.
and Francesco.
How are
Um,
you?
good, thanks. Yeah, so basically, as Wenge said, Alex was kind of like the pioneer of actually implementing this stuff on Forest and also on Map. So he kind of like, yeah, made the first implementations of the model. And everything that I did was basically aimed at scaling that up, as Wenji said, to make it feasible to do it on the global scale. And there's a bunch of different sub parts of that. So some of the work was, just actually fine tuning the model. We did a lot of stuff like that. Um, from the development perspective, that necessitated making like a configurable implementation of the model so that you can like tweak the parameters and data processing flow without like rewriting the code every time. So that's part of it. I don't think we're going to go into super detail of that part today unless you guys want to know, unless you guys kind of want to see like under the hood. There's like I say under the hood, but this stuff is like there's like seven hoods, like stacked on top of each other. There's like so many layers of abstraction because of how map is. But anyway, so that's part of it, like making the model more configurable and actually fine tuning the model. The other big part of it is just automating the map runs so that we don't have to like figure out every time all of the URLs of all of the files we want to run on, and to try to avoid as much as possible having to do a bunch of like resubmissions and reruns because every time you run stuff on map, some fails typically because of like network issues or just AWS availability.
Yeah, so I think everyone has a MAP account. MAP is like a cloud. I don't know, Francesca, Alan has how much like you've been diving into this. For it's like a cloud system. No,
Yeah,
it's a
I can give a little
yeah,
a
yeah,
little background on MAP if you want.
yeah,
Um, were you saying something, Alex, before?
yeah. Sorry.
Yeah, those failed no those failed jobs. You said that sometimes it's networking issues. I was thinking that's what it could be, failed packets or something. Is that an answer you got from Sujin or someone, or is that kind of your guess?
I Yeah, so definitely Sujin, when I've asked him about this kind of stuff, he says um, a lot of times he's like, yeah, it could be transient network issues. Also, just a lot of those, you can see like the exit
Awesome.
code
Yeah.
of the jobs when they fail. A lot of them have 143, which is the exit code that would correspond to Amazon reclaiming a spot instance, which they can do, and kicking you off. And also
Okay.
just the error pattern that I see is like a lot of times a given job will succeed one time but fail another time. So it's not deterministic. So it's probably not something in the actual algorithm. And also like at first, of course, when I was implementing this, there was a lot of there were just genuine failures. Like I tried to divide by zero or something like that, and I did a lot of debugging on that, and then eventually there was just a pattern where it's like every time I submitted a big job, like maybe 5% of them would fail immediately. And then if it lasted a long time, like some other percentage would fail. So ultimately it seemed like, and like which 5% it is not determined by the parameters. It's random. So all of that made me think this is probably just about like the map infrastructure and or the AWS availability.
Yeah, that's a good point. And so when you for dealing with that, do you like catch that, save those files, and then rerun it again? Is that something you're doing in the code or?
I'll show you in a bit. It's something I've iterated a bunch of times, but now I actually have a thing where, well, you'll see. So I have like a status bar, like job monitoring essentially as it's running. And at any given point, you can suspend that bar and then you have an option to like resubmit the jobs that failed. So you can actually do it like on the fly. There's also an option to mark a run as a redo of another run. And in that case, it'll look at the outputs from the previous run and it'll just not do any of the stuff that you already got outputs for. So there's like the runtime version and also the
Post.
retroactive version. Yeah.
Okay, great. Yeah, I mean, you don't have to get too into the details. That's kind of my only question. So thank you.
Okay. Yeah.
Okay.
And I'll show you a little. I'll run something. Hopefully it works in a little bit, and we can see. Um,
Yeah.
Or if it works to fail.
Before Ian, oh, sorry, go ahead. Before Ian start, I want to say something. For this model, we take a Jedi waveform, but we also need some of this allometry information. So Ian already published just out, right? He's
mhm,
a part of
mm,
his master thesis work, and just he analyzes this global tallow vegetation structure data, trying to really parameterize this high scaling exponent,
yeah.
required by the model
Yeah.
using global data.
Yeah.
Sorry.
Thanks for bringing that. Wait, is that a hand raise, Alex?
Yeah, man, it's 2025, dude. You're
I don't
streaming
zoom
live
that
right
much. What's up?
Yeah.
Um,
Applause. That was cool. Yeah, congrats.
oh, it was like a, okay, thank you. I thought you were
Oh
like
yeah,
asking
yeah, it was
something. It
applause.
was it was like a yeah. Anyway, okay, so yes, thank you for bringing that up because I forgot to say this. That was another big motivation because Alex's implementation was like pretty like fast and simple, which are like good things. And I ended up making this whole kind of like backend for it that is more complicated, but a big part of the motivation was being able to support like dynamic allometry. So I don't know, Alan and Francesca, how much you've like gotten into that stuff, but big picture, it's just that like allometry is just in our case, a set of numbers that describes our expectations about the shape of trees in different areas. So it's like in some areas, the this trunk of a tree is going to be wider compared to how high it is, and we only have access basically to height. So insofar as those assumptions about tree shape change with like where you are in the world and how dry it is and the species and all of that, we need to try to account for those differences by varying those parameters. And this was kind of like my entry point into the project, because when I started working for Wenge, my first project was like analyze allometry, and so then when I started building out this map, well, this model implementation, I was like, okay, we need to be able to like dynamically provide allometry as flexibly as we want, and that was the motivation for building a lot of this stuff. Ironically, ultimately, when we've actually tried with like the more flexible allometry, tend to get into a situation where it's like the more fine-grained allometry is noisier because it's based on like the more geographically fine-grained you go, the noisier the allometric estimates are because the sample size is smaller. So in practice, we've ended up doing pretty pretty coarse allometry anyway, so which is funny. So maybe we'll figure out how to do it, maybe not. But like here, let me show you really quick. Actually, like this I have up. This is like, oh man, I really don't want to unrender this. This is like for the CONUS runs, the current allometry raster that we're using, and it's like, well, why would you use a raster? I mean, it's just two, it's just two values, and that is a good point. The reason is that we thought it was going to be more than two, but anyway, this is kind of like what we're dealing with now. This is like the parameterization. Anyway, oh no, now it's going to have to re-render. The actual results take a very, very long time to render because, look how many there are.
So
Anyway,
you finished 5 years run for Connors?
still got to do 2024.
Okay.
I finished everything with 2024. Yeah.
Hey, yeah, so that's a good point. Sorry, Keith. The output is going to be one large file, right? So we should probably tile it after the output if we're doing.
So the output is actually not by default one large file. I combine these, and I'll explain. Tiling is a good idea, and it would be totally like doable to implement. In practice, like for my project, I'm looking at this kind of thing, right? Like the FIA hexagons.
Yeah.
Mhm.
Okay. I can
Okay.
talk about this a little bit. So,
Oh yeah, sure.
yeah, so I think Ian run this model for Gabon as one of country in tropical forest, and we're using the parameter like come from his paper and also one local one. So that's actually yeah, Alex says it, but we're gonna submit like this week probably sometimes version. And then we work on another paper trying to run this in the corners. And Alex did this comparison long time ago, but compare with the old FA data, FA biomass. Recently, I think last year, they come out with new allometry. So Ian was able to download the new biomass. So he's going to compare this output with the new biomass. We're
Yeah.
gonna,
Well,
yeah,
wait, and even I mean, I didn't think to, but I can bring up the scatter plots and once we get to that
yeah,
point.
sure.
But
Yeah,
anyway, yeah. So to your question about tiling, wait, is Alex gone, or it's just not in my little? Hold on. Are
yeah.
you?
Hey,
Oh, sorry. Okay, you just weren't in my little stack of people, so I was like, oh, I thought you left or something. But anyway,
yeah.
so on map, um, the like map output, it writes its jobs into like a hierarchical, or it writes the outputs into a hierarchical folder structure that's like based on timestamps essentially. So when you download, I'll get into how you do this the proper way. But when you download the results from MAAP, you're gonna get it in that like native structure. So you will have access to all the individual files, which is actually kind of important because like for a processing task like this, like aggregating across 3,000 output geo packages into these hexagons, it's much easier to do that if you still have the original small files and you just like parallelize across those 3,000. But once you want to visualize or something, you need to just dump it all into one giant thing. So that's why what I did is agnostic about that. It just gives you the actual map output. But yeah, I'll get into the details of how it works. Okay. Should we jump into the actual thing, like the
Yeah.
map platform? Or
Do you guys have any other questions for Ian before we start talking into the details?
Just generally, the inputs and outputs, you said there was a geo package as the outputs?
yeah.
Okay, so that's the format of these hexagons, basically.
Well, actually, so the geo packages that are the outputs are these points. This is like, say it gives you like 3,000 geo packages as an output. One geo package will be like half of one of these orbits of points. And this is everything aggregated together. And then as a post-processing thing, I aggregated them into these hexagons. And you could do that. You could implement something on MAAP to do that. In fact, that's what Sujin wanted me to do. He was like, because I was asking him, how do I actually get the data off of MAAP, like onto Forest or onto my own computer? And he was like, why would you want to do that? I was like, what do you mean, why would I want to do that? Like, that's the whole, like, I have to process it. And he was like, no, you should process it all on MAAP. And in theory, that's a nice idea, but MAAP's process for like registering algorithms and running them just, in my experience, slows down development a lot because it's kind of a slow Docker build so every time you need to change something, it just makes the cycle pretty slow. So for post-processing, I prefer to just get the output and do it on, in my case, my computer, but you can also do it on Forest or your computer. Yeah.
So sorry, you said your output, each file is for one of the output from footprint, per footprint.
Not per footprint, per orbit, per granule. Remember the other day we were talking about granules? Yeah, so the Jedi files are organized so that I think it's half, this is one, like, you can see this is one orbit, like going all the way. And that goes all the way around the Earth, but it's divided so that maybe it's more than two. Maybe Alex remembers, I don't know, but it's at least split. So one granule, which is like NASA's unit for a file, essentially, is a part of one orbit. So the output, so one output file will be one part of one orbit. Yeah.
And I assume in the post processing, you combine the results, the overlaps here, basically. If there's overlap, you combine.
Yeah. So like, it depends, right? Like for a long time, I had a different like workflow that was slower where I would combine everything together, just with like GDAL, and then I would load it into PostGIS and then process from there, because it actually, like, it has the power to deal with that. Of course, you could also just try to use like Dask or Futures or something in Python and parallelize the processing on your own by tiling or something like that. but then at a certain point I was like, wait, I don't need to tile. I can just not aggregate and like parallelize on the small outputs. So now like I have making these hexagons is fast because it's just a script that runs like on each on each output file and then aggregates all of those results. But yeah, as I said, like it's the post-processing thing is kind of up to you. If you're using this, it's like what you want to do with it. What my tool will give you is like an exact copy of what MAAP would have given you on its platform.
Oh, can you explain to me? So how did you do this for each of these hexagon? Do you have a view package for per granule?
Yeah. Yeah, I would have to look and remember the details, but the overall idea is you have the map of hexagons, and then you just look at one file at a time, and you're just like basically keeping track of how many shots, and then
Yeah.
keeping track of the average. So you can weight the average appropriately depending on how many shots are in each file in each hexagon. And then like the final aggregation step just like calculates the proper weighted average across those 3,000 files for the hexagons or something. I can show you the actual script if you want.
Okay. Okay.
But that is not a core part of the actual tool.
Yeah.
Like that is
Yeah.
like that's like for my project. But,
Yeah.
okay, so yeah, maybe let's get into the map things. Because map is like so complicated. And it took me so long to understand how to actually use it properly.
Yeah.
Um,
Yeah.
yeah, one second.
So one advantage of using map is that you don't need to download the JEDI data, right?
Yeah.
Is that right?
Yeah,
Okay.
this is like the big benefit of using map. Well, there's two things. One is it's faster typically for big runs because you can run, you'll have typically you'll have 1 to 2,000 things running in parallel, depending on how the dispatcher assigns the jobs, but that's compared to like 40 you could do in parallel on the server. So for a big run, like all of the continental United States for 1 year, it takes like an hour or so, which is not bad. Again, depending on like network availability and stuff.
Wait, so the data that's on the Forest server now, the biomass data that's already on there, I think
Yeah.
for 2020 to like 2023 maybe, is that the same as what you're showing us? Or is that the same output as the script that you're going to show us? Or is that
That's
a,
probably from when Alex was running Conus runs on Forest, my guess is. Does that check out, Alex?
Are you referring like for your site only, or you're referring like for the whole US corners?
um
And Alex directory, you mean?
I think so, yeah.
Yeah, that's an old run he did.
Yeah. I personally have never done big runs that were not on map. Like all the big stuff that I've done has been on map. So probably if there's a bunch of data on there, it was from Alex, I would think. But we can definitely, I mean, it is a lot of the same data, of course, and we could totally use that. I am going to focus in this meeting on the map part. But in theory, well, not even in theory, like I have done this. You can use like the same backend that I wrote and run it on the server. It just takes a little bit of doing, and I don't have as nice of an interface for that. So I'm not like that hasn't been so much my focus because all my stuff has been map.
Gotcha. Okay.
Yeah, but you can totally do it. But that being said, you can also use Alex's code to run it on the server. Although at this point they are slightly different in the implementations, but Alex is probably faster for that, I would think.
We should talk about that version later on because
Yeah.
because like maybe Francesca want to run it, and also this the JPL person want to run it, and probably we want to kind of give them a version they could
Yeah,
run.
it would not be that hard to do. And I wrote a couple guides which I'll point you all to. And one of them has instructions for like how you would do that.
Mm.
But it's
Okay.
not but it requires a bit of doing. Like it requires a little bit of coding. It's not just like a tool that's ready to go.
Okay. Okay.
Um,
All right.
all right. Well, yeah, let me get into this. Hold on.
So, I think just a little bit of clarification. If it's
Yeah.
Alex output, I think that right now the only difference is like Ian implement on more strict like filtering, right?
Well, remember there's also some slight differences in
Uh,
like the
I
segmentation of the
remove
waveforms.
removing the ground return point.
Removing the ground return, yeah, that's but I mean none of it makes a very big difference. We tested it and it's like marginal.
Yeah,
But yeah, there are slight differences in the implementation. Yeah.
but
Just
I
because
think the
of
filtering right now is more strict, right?
um so right now the filtering uh I think I with the sensitivity thing you mean?
No, the
I s-
filtering the bad
yeah,
waveform.
but filtering on that sensitivity parameter, right? That we yeah, but the filtering is a little bit different
Yeah,
than Alex is in either case. Yeah, it's true.
yeah.
Anyway, let me just show you guys how to run it and like what it looks like. Um, you can see this. Wait, if I go over here, can you now see map? Or is this still?
Yeah, I see
Yeah.
maps now.
Okay. Okay. Oh wait, maps. Oh, am I still showing you QGIS?
No.
Oh no, okay, it's actual. That's. I really wish they hadn't called it map. It's like a source of endless confusion. But anyway, okay, so there is this on the GitHub for the project. There is a guide which walks you through how to use the current version. Um, so yeah, I'll just put this link in the chat if you just for
Yes, thank
reference.
you.
Um, I just updated this, so it should be up to date. But if something looks like it doesn't make sense, let me know. I think it should be good. We'll see. Okay. So first thing you have to, in order to run this version, you have to create some rasters that are maps of the parameters that you want. It's been on my to-do list for a long time to make a version where you can just provide constant allometry, because in many cases, it turns out that's what you want to do. So you don't have to make these maps. But for now, if you wanted to do that, you could just provide a constant raster, which is a pain, but still works. And yeah, I've just been a little bottlenecked by registering the versions, like how map treats arguments essentially, and registering the versions to make that version. But anyway, for now, you have to provide maps of HSE and K-alarm, which is a coefficient. So what those both mean are kind of in the weeds, but they are parameters that describe, yeah, like I said, essentially the patterns of the shapes of trees. So that map that I showed you before was like two sides of the United States. That was such a parameterization. The important thing is that it covers everything you want to cover. Stuff will just get dropped if it doesn't get a value from that raster. So if you want to do the whole continental United States, you should have something that has parameters for the whole continental United States. Then you also just need a polygon that is what you want to process. Like you could just make that from the rasters, and then you'll be totally sure that your rasters will parameterize everything. But you could also just, in my case for these runs, I just made, used a conus boundary polygon. So that's another thing you need. there is a processing pipeline, like there's a configuration file that configures the processing pipeline. And you only need to mess with this if you're messing with the actual behavior of the model, like the filters or the way that it segments waveforms or anything like that. So this is kind of like a lower level, or like this is at a more granular level, I would say. And so if you're just using this model like with kind of like the default, or what I did, you can just use the existing config file. But I'll show you what it looks like for context. One second. Yeah, so this is like the most recent ones I'm doing. So this is the configuration file. Can you all see this? It
Yes.
switched over, okay? Okay. This is a configuration file. It basically has two sections. The filters, this is what's determining what waveforms you're gonna gonna process on, and which you're gonna exclude because they're low quality, which is a really big deal with Jedi because there's a lot of messy waveforms, presumably because it's spaceborne. I mean, there's not a lot of spaceborne LiDAR for that reason. It's pretty hard to get it clean. So yeah, I mean, if you're interested in like changing the filtering behavior, there's like a filters.py file that defines what all of these are doing. But realistically, you should just ask me and I'll explain in more detail. And then this is the processing pipeline. Each one of these is like configuring one step of processing that gets passed to the next steps. And yeah, I mean, it's a complicated process, but again, you would only want to mess with this if you were like in the weeds of the model. I don't think that would be necessary. But if you did, just yeah, let me know. What was that, Francesca?
Hold on. Wait, I'm gathering my thought. Okay, so
Sure.
so the step one, creating parameter raster, if you want to, so if one were to change that, I don't know, maybe to like get better information on like what trees are there to calculate the allometries,
Yeah.
this pipeline you don't need to touch.
Correct. Yeah.
Okay.
Yeah. This is, I mean, I'm showing you this because it is formally an input to the MAP algorithm because MAP needs to know like what, like I essentially, I didn't hard code the particular processing flow because it was changing a lot when we were fine tuning it and iterating it. And also like it could change. It's like it's an experimental technique, right? Like this whole model is experimental. So it's, this like makes it so that you don't need to like go into the code every time you want to tweak something about the configuration. The other big motivation for this actually is that, man, I'm gonna get too into the weeds, but just quickly, I'll show you like, these are all referring to functions that are defined in an algorithms file. And the idea of that is that it decouples like the actual science processing, like the math that Wenge came up with. It decouples that from like all of the data engineering that needs to go into making this work. It means that if you want to say you're like, I want to tweak the behavior of how the segmentation is working, then you don't need to worry about all of the complicated data loading and whole like rigmarole of map. You just can go into the relevant, sorry, this is insane because there's so many run output folders. But anyway, you can go into this algorithms.py file, and this is where like the actual model behavior is defined. And you'll notice like in the imports, there's nothing weird here. Like it's not importing a bunch of like objects that I designed or something. It's just like pretty much pure functions. So the motivation of that was like, if you're a scientist who just wants to think about how how exactly the math of this model is working, you can do that by looking at the algorithms themselves in isolation from their context in the whole like map pipeline. So
Okay, so to maybe reiterate what you just said,
yeah.
the math part is separate from the pipeline. The pipeline is dealing with how you're getting the data off of maps or the images from
Oh,
Jedi.
sorry. That was a little confusing of me to use pipeline in two different ways. So this pipeline, like you'll see these things, like these functions, normalized waveform, these are referring to functions that are defined in the algorithms
Oh,
file.
oh, okay.
Yeah. So when I said the map pipeline, that was my bad. I didn't mean the YAML pipeline. I just meant like there's so much complication just involved in like shuttling the data around to make it work on map. And I just wanted to isolate the model from that.
Gotcha. Okay.
Yeah. Um, yeah. Okay. So so typically you wouldn't mess with the configuration file. You would just use the one that exists. But you know, if you get in the weeds, you could. Um, you need to clone the repo into your map environment, just like you need to do that to run anything in map. And then you need to get your input files into map. So you will now have your configuration file on your computer, and you'll have your HSE and your KLOM and your boundary, and you need to put those onto the map system so that it can access them. The way that I recommend doing that is in your private bucket. So I have like an inputs directory in my private bucket. So these are the ones I've been doing recently. So we have the configuration, we have HSE, we have KLOM, and we have conus.geopackage, which is the boundary. So now we're basically set to run it. Okay, so are we all, any questions up to now? I know this is like, believe me, it's confuses me too. All good? Okay. Okay, so all of the point of all of this is to enable a script that automates the job design and submission and monitoring to map. Because what map actually has is the system where you register an algorithm. They call it an algorithm. That's kind of their term. Like not an algorithm in the traditional sense. A map algorithm is a thing. You register on their system, and then that gives you the ability to run that algorithm on Amazon like worker computers. But map does not itself like automate the process of submitting a ton of jobs and monitoring them and like managing them. So even if you've got your thing on map, then you're going to have to make like a script or a notebook or something that figures out like what are all of the parameters I need for all of my jobs. So you'll need to know like all the file names essentially for the input files. And then you'll send those all off. And if it's a really big batch, you just kind of pray, because now you have 3,000 jobs out there and you can access them, but it can get a little hard to handle, and it can get a little complicated to understand exactly what's going on when jobs fail and stuff. So this whole part of the project was about just like, as much as possible, automating that so that if a member of our team can say, okay, I have the configuration file, the HSE map, the KLOM map, and a boundary. So like, I know where and when, and also like a time range, let's say. So I know where and when I want to run the model. They can now run that with no further work. You don't have to then go and figure out like what files do I need or how am I going to set it up to run. Like this will take care of all of that. So that's kind of the idea, to make it accessible for like, if you wanted for the bird-friendly coffee project to see like to get like a Jedi output for those areas of Colombia or something, you could just do that. You know, you wouldn't have to figure out exactly what files that would need and all of that. Okay. So next up, so I was saying, you want to put it in this input file, and then you run the actual script from the terminal. So what I recommend doing is tell the terminal where your input file is, or your input directory is, right? So you're going to do something like this. Input directory is this path. You'll notice it is an S3 path, not a local path in the MAAP file system. And that actually brings me to an important point, which is they don't really tell you this on MAAP, but it's actually really easy to break the MAAP platform for everybody temporarily, because the actual what they call the algorithm development environment, which is like what's running this workspace, is a shared resource. They tell you that up front. It's a shared resource. And all of this, like these locally mounted folders that just look like a normal folder system, this is all backed by Amazon Cloud Storage. Like there's an S3 bucket with all of this stuff in it. But the ADE cluster is doing the work to mount that bucket as like a local file system, which means that you can access links to, like I can get a path here, and the path is going to be my private bucket / input / conus59 / conus.geopackage. That is formatted just as a local path, not as like an S3 path. So an S3 path is something that Amazon's S3 service understands. Like you give it that and it gives you whatever's at that location in the bucket. This is not like that because it doesn't begin with S3. This is a locally mounted path within the MAAP file system, right? So if you tried to download something really big just by doing this, like clicking here and saying download, it actually routes the download through the ADE because you're accessing it through the local path. And if it's really huge, that's going to take a lot of like network traffic in their shared limited ADE cluster. So then people on Slack will start saying, why isn't MAAP working? And you'll think to yourself, oh God, was it me? And it will turn out to have been you. This can happen pretty easily. So the point is, you're not supposed to do that. You're supposed to download, if you're downloading big stuff from MAAP, you download it using like the Amazon AWS S3 command line tools, because then you're just routing it through like the S3 service. You're not going through ADE at all. And so that is a really long-winded way of explaining why, in this case, I'm giving the input directory as an S3 path, not as a local path, because MAAP is going to grab everything in that input directory, and not everything, grab what you tell it from that input directory and send it to all the jobs. So if you're like dispatching 3,000 jobs at once, this also can cause network problems for the ADE if it's looking locally instead of through S3. So make sure that's the S3 path. I asked a long time ago, I suggested to the MAAP people that they create an option here that was like get S3 path, because that would make it a whole lot easier. And they were like, and by the way, this get pre-signed S3 URL is a different thing. That will not give you what you want. So they were like, that's an awesome idea, but I think they're pretty busy and never did it. So what you need to know is that MAAP ops workspace is the bucket. You need to put your username, and then at that point, you are in what is locally mounted as root, and you should be able to you should be able to find whatever directory you need from there. So, okay, so I recommend doing it this way because then you don't have to retype input directory every time. Just refer to the input directory below in these options that you need to give. But what are these options? So you can look at them. Am I in the right place? Yeah. So you can see what these options are actually by running Python run on map.py help. And this will tell you what are all these options that you need to give to run this. Most of it is pretty clear. So you need to tell it your username. I guess I could probably configure it so it could figure that out. But for now, you just need to give it your username. You need to give it a tag. A tag is like associated with one run, and all of the results under a given tag in the map system are going to be stored under one like directory. So the tag is important, and you want to make sure that you're not giving a tag unless you really mean to. You generally don't want to give a tag that you've already given before, because then you'll be writing into that same like area of the bucket, whereas probably you want to keep the runs separate. But yeah, it can be whatever you want it to be. So it'll be like Conus run, this one will work, or whatever. So the boundary, you're going to give it the path to the shapefile, or to the boundary. The date range is a date range in the NASA CMR format for dates, which is explained in this guide, and also you can look it up. Then this is like the config is just the path to the config file. HSE is the path to the HSE raster. KLM is the path to the KLM raster. And now you need to give it the name of the algorithm, which in our case is what is it? NBIM biomass index. NBIM meaning Meister biomass index model. A creation of our co-author Nancy, who was like, you need an acronym for this because we can't keep saying the model. And then version. The version is just like a Git branch. So just say main. Job limit, mostly useful for testing if you want to make sure that it only submits some low number of jobs. Also, in general, I would give it, if you're running a big job, still give it some high limit. Like I typically give it 3,000 because I just want to make sure it's not going to do more than that for some reason I missed. Then you have a couple other options. So redo of means you give it a tag of something previous that you did, and it's going to look in that directory and see what completed successfully, and it won't do that again. So the idea is like you did some run, it half worked. Now you can do the run again and specify redo of that tag, and it won't do again what already worked.
The job tag, the
Yeah.
/t. Yeah.
Yes. Yeah. Exactly. It's the same thing. Yep. Okay. So I made it so that you cannot put the same thing as tag and redo of, because that would mean that you're now writing your redo into the same thing you did a redo of, which, okay, that could be convenient. Maybe it's what you want, but now also you've kind of lost information because you're melding two model runs together. So by default, if you try to put the same thing as for tag and redo of, it's going to say you can't do that. But if you're like, no, I really want to do that, you can put force redo, and then it'll let you. Okay, then finally, as you'll see, there are some options for as the algorithm is running, you can resubmit some jobs. Like once jobs fail, it lets you resubmit those failed jobs. I'm still, that mostly works, but I'm still debugging some weird map stuff with it. But it's worked pretty well for me so far. But if you put no resubmit as a flag when you run the command, then it won't let you do, or it won't ask if you want to do that. So if you're like, I'm sure that I just want to let jobs fail for whatever reason, you can put that. Okay, so that's all the options. Any questions about any of that? Okay, let me know if you have a question. I'm going to run something. I think. So, well, let's see. So this is the one that I put together to run here. So my username, this is the tag. I'm calling it conus bifurcated because it's those two big chunks in the allometry demo live for obvious reasons. This is what the date string looks like. So this is saying from January 1st, 2023 to January 1st, 2024. And then here is how I'm referencing the input directory using this, right? Like if I didn't do this bash variable, then I would have to rewrite this whole path every time, which is annoying. So that's where conus is, configuration file, HSE, kalom, biomass index, blah, blah, blah. Okay, so let me just do a really quick one where it's only going to do 10 jobs, just in case I screwed something up so I can fix it. All right, so it's finding all the granules, it's submitting all the jobs, and now it waits 10 seconds for the jobs to start because we want to give them a second to like spin up. And then now we're in monitoring. So now these are all the states that a job can be in. Submitted is just, all I know is I submitted it. Accepted is something that map tells you. It's like, we're gonna run it, but we're not started yet. Running is, it's running. Offline means that it has been suspended because there's not enough AWS instances. So it's like, it hasn't fully kicked you off and failed you, but it's suspended it, and sometimes they resume, sometimes they don't. Sometimes they just get stuck there. That's succeeded, failed. Deleted is when you cancel it. Other is a catch-all because I don't have a complete list of the possible states. I think I know all those states, but maybe not. And then this just tells you how long it's been running for. So yeah, we can wait for a while until they get into some other states, and then I can show you some of the options.
So where's your area now? Conus?
This is conus, but it's only running 10 jobs, essentially selected at random.
Where did you tell the 10 jobs? Because I think I see your January starting 2023,
Here.
January 1st, all jobs.
Yeah, J10 means it's a limit of 10, so that, for whatever demonstration. So now we see, okay, 3, they're all running now. This is designed, by the way, such that it should be nice on the API. I have it making like 10 requests for status at once, and then it waits. And then after doing that 10 times, it waits for like 30 seconds. So I think that should be reasonable, but I don't know because there are no official like specs of the map like server. So so yeah, maybe at some point in the future you could always turn it down and make it check less often, but so far it's been okay.
So these 10 jobs, so do you know where is it? You don't really know the first 10.
No, just somewhere. No, it's just like the first. Well, actually 9. It's the first 9 that I found. Probably it's doing 9 and not 10 because it makes 3 different requests, right? One for each of the products. And if you're doing like normally you're doing like an exhaustive run where you're like, I'm going to get everything that meets these criteria. But But in this case, since we cut it off randomly, there's some possibility that like we got an L4 file that didn't match the other ones. So then it matches them up and it's like, this one doesn't have a match. So it only does 9, which is not a big deal because normally you would never purposely limit it like that. But yeah, that's what's going on. So I'll just show you, like, if you do Control C at this point, it says monitoring suspended, enter R to resubmit failed jobs, X to exit, or wait 10 seconds to resume. So this is what I was talking about. If jobs have failed at this point, you can do R and it'll start the failed ones over. That's the part that 90% works, but basically, I think sometimes MAAP thinks that it's a duplicate, so I need to tweak it. There's some behavior about MAAP that I don't fully understand there, but it has worked for me so far. And then
So-
yeah, you can also exit there.
So is your code on MAAP available, for example, Alex on MAAP now? Could he just like do the same run?
No, of course, it's just right here. I mean, you need to clone this repository.
Oh, you have to.
Yeah, and I mean, it might take him a second because he would need to copy over the configuration. But yeah, it's public. I mean, that's actually a requirement of MAAP that you make the code public. So it is. Yeah. Yep. The other
So
big part of this that I need to show you all is the downloading part, which is not as complicated but also important to see.
So Alex, was you able to run it while Ian talking?
Well,
Oh no, I
he's-
wasn't doing it. Yeah, I wasn't doing it as we're following along, but I'm familiar with this whole architecture.
Oh,
Yeah.
okay.
Yeah, he could definitely do
Yeah.
it. Yeah, so is there anything we should talk about in the meantime? Or I mean, I can forge ahead and show you the downloading part, but I mean,
Yeah.
I've been talking for a while.
The TIFF files, you create that in QGIS basically, or just
Yeah.
any program?
Yeah, no, and I mean that's really the biggest. Like I have, because of some MAAP complications, I have a weird situation where I like implemented a version where you don't have to provide a TIFF file, you just provide a constant, but it's on a different branch, so it's not registered as this in this like main branch. And I just wanted to show you the one that like 100% works, or at least 95% works. So yeah, it's annoying to create a TIFF file. I mean, you can, like, there are funny little ways with like GDAL and stuff of making a raster that is like one cell that covers the entire Earth and has one constant value. So there are hacky ways of making it work for just for constant. But like it's done. Like it definitely needs a constant value. The problem is that the MAAP interface does not support optional file arguments. So it's like if I set it up to take HSE and KLM as maps, then I can't, in that same algorithm, I can't have it also have a constant option because it's always expecting a map. It's always expecting like files for those arguments. So I need to register it separately to have like a constant version.
So okay, this TIFF file is a raster.
Yeah.
Is that right? It's a raster has the area where you run? Has to be.
No, there's a vector boundary that is the area where you run. The raster should cover that area, but the raster has the values of the allometric parameters.
So
there's-
each time, I understand. So I don't know, whatever resolution you have this HSE value. So when you run, you get a JEDI footprint, right? Location. You just look for the same location in your raster to call that value.
Yeah, it'll read the raster for each location. Yeah, that's right.
Okay. All right. So this raster file have the same area as your polygon, right? Yeah.
It should. I mean, it's up to you. Like you're providing the inputs, right? So it should.
No. No, say for example, if I give you this TIFF file, give you say Conus area, but I only want to run say, I don't know, one state, for example.
Okay, yeah. So you could give rasters that have parameters for the entire country
Uh-huh.
with a vector with a boundary that is smaller. That's fine. Yeah, and then
Oh,
it'll
that's
just run for one state.
okay.
You just have to make sure that the boundaries fully this is right that the rasters fully parameterize the vector that you give it. And this is what I made a whole this is annoying, right? So I made a whole different solution to this problem, which is arguably a little bit unnecessarily complicated, but I ran into this. Ultimately, I realized you're going to have to register separate versions on map anyway because of this optional file argument issue. So really, you should just have a separate branch that is like, this is the one that takes constant values, and just register that separately on map. I haven't had the time to do that, but that's what should be done to make it useful for running like small areas, where you don't have to worry about allometric variability.
Yeah.
I mean, you still could do it, but you just annoyingly need to create the
Yeah.
maps. Yeah.
Okay. So maybe eventually it will be interesting, like based on your paper, I don't know, Alex could do it. So based on the output from your paper and could create this TIFF file for different continent at the different whatever, like a biome
Yeah.
case. Is that
Yeah,
right?
yeah, totally. You could make, that's actually a really good point I had not thought about, is you could make a global parameterization,
Oh,
and then you could, because when I've thought about that, I've always been like, but then you can't really run the whole globe on, the whole globe is too big for map. You want to do it more on a continent per year basis, I think.
yeah.
For it to, otherwise it gets unwieldy. But you're right, like we could do the parameterization part of it where it's like we just make the global raster and then we just pass that into every job and that would be fine. Yeah.
Yeah, right?
Yeah,
Okay.
that's true.
So what is the spatial resolution in the raster? You're using?
For this one, chosen pretty arbitrarily because I was just splitting the country in two.
Yeah.
Let's see. So yeah, I don't know, what is that like?
Yeah, because regional, right? It's a constant rating,
It's
like
like
for biome.
oops. The spatial resolution is.
Yeah, probably doesn't really matter,
It
right?
doesn't matter a ton, but I'm curious
Yeah.
now that you ask. This is it's like a kilometer or so,
Oh, okay.
approximate. Yeah, but it probably is a kilometer actually.
Yeah. Okay. That's good.
Yeah. So, okay, so you can see we're 22% done. Nothing failed, so there's nothing to resubmit. Yeah, succeeded 3, running 6. Okay, so this is going. I guess I should just cancel it at this point so I can show you the cleanup because we're not actually going to look at this data.
Yeah.
So if you go into this suspending and then you hit exit, it exits gracefully, which means it cancels.
You're sharing only this map, the QGIS.
You missed the exciting moment. Okay, hold on. Okay, so what I just did was I paused it. So it was 33% done, right? I paused it, I hit X, it exits gracefully, which all that means is it needs to tell everything that's still running to cancel, because otherwise it's like kind of a waste of resources. So it tells every running map job stop. It does that, then it's like, okay, I did that. And then it gives you a summary of the run. So we had it running for like around 12 minutes, submitted 9 jobs, a third of them succeeded. And then these are the final statuses of all the jobs. So 6 ran, 6 were still running, 3 succeeded. And now there are some jobs that didn't, obviously the ones that were still running did not complete successfully. So you can go into like whatever directory you ran it from. You'll get, I have a million of these because I run it so many times, but you get these outputs. And one of the outputs you get is unsuccessful jobs. So these are the 6 jobs that were still running. And so I can open them up. This is the ID. This is the final state it was in was running. And then these are all of the arguments that were used to run the job. So if you wanted, you could use this JSON file. You could just iterate through it and like literally run exactly the jobs that were unsuccessful. So that's another way that you could deal with the redoing issue. The other things that are in here are, this is just all of the job IDs that were involved in this run, which could be useful for debugging. And then you have the log. This is just the log that ran, or this is the log of that run. And it copies over the configuration file because it could be important. If you have different configuration files, you want to make sure you know which configuration you ran with this job. So it copies it over just so you can be sure. And then the other thing is, the other thing to be aware of is if I look, well, hopefully some of these actually produced outputs. Sometimes a job succeeds but doesn't produce outputs because there weren't any good shots in that area, which is fine. But I would like to show you what it looks like. Well, anyway, actually doesn't matter. So you get, this is the log of that of one job running on one computer. So you can see everything, or is it this one? I think it's this one. Yeah, sorry, it's this one. That's a little confusing. Run.log is the one that is actually the worker's log of running the whole model. So you can see everything that happened. Wait, am I tripping? I am. Okay, sorry. It is output.log. I never look at these. I'm sorry. Run.log, I guess, is basically the same as the other one. Output.log is all the details of the processing. So this is saying like, no waveforms were written, no waveforms were written, no waveforms were written. It's because there weren't any good waveforms within that shot within the area. So point is, you get another level of like inspectability if you want to see what went wrong with a particular job in your run. And then these are like, this is just the standard output. So it's actually a lot of the same information, but this is provided by MAAP. Anyway, yeah, that's
Okay.
that.
Okay, I have a quick question for someone
Yes.
that I know background on that. So you
Yeah.
said you have to register the job, the model, right? What
Yeah.
can you tell me how did you, I mean, you don't need to tell me detail, what is the process you have to register? I mean, if you say Alex download the colonial code, does he need to be, say, the register first?
No, so the thing that is registered is the program that tells one worker to run one set of files, like one L1B, one L2A, one L4A. That's what needs to be registered. Like that's like the underlying one computer running one set of files script. So if you change something about the actual model implementation that would affect that, then yes, you need to re-register. But if you change something about like this outer tool, like this outer script, for example, then no, you don't, because the underlying implementation remains the same. And the way that you do it is you kind of need MAAP to train you on it. It's a little bit of a whole thing, because you need like, there's like you basically need to create a repository that has like a run script and a configure and like an environment script and all of that. And like, that's like, Alex knows how to do that for sure.
He needs to, if he clone your stuff, he needs to do it.
No,
right?
not if he clones it. If he wanted to change the underlying model, but not to run it in its current state, you don't need to do it. No.
Okay, so if he clone it, he doesn't need to.
Correct.
He doesn't need to.
Yeah,
Okay.
It's the registration is not on a per user basis. It's like registering an algorithm is like adding something to MAAP's bag of tricks that anybody can access. Yeah.
Okay, I see. Okay, good.
Yep.
Good so far, so good. Yeah, that
Yeah,
makes
it's
sense.
complicated. I mean, the platform is
Yeah.
pretty complicated.
Mhm.
All right.
Can I actually? Do you think
Yes.
you could resubmit this job with the -r tag? Just, just.
Yeah, it won't do anything though, and this is because the way so the reason that I made the reason that I made the like in running version of that. I actually let's see if I can let me resubmit just in general, but with like 500 instead of 10, and then maybe we'll get some failed and see how that behaves.
Okay, so
Um,
it only works for failed, not user
well, here's the deal. So
restaurant.
it only excludes jobs that had a geopackage output. So that's an even smaller subset of the jobs than failed jobs, because some jobs are successful but don't produce anything. Those will run again using the like redo of tag. Um, and so that's a little bit inefficient, which is why I was like, when we still have the state of the jobs in the running session, that would be the time to actually do the redos. That's why I set it up this way. You can see in this case, by the way, it's submitting the jobs and it takes a lot longer because there's many more of them, and also it pauses to be nice to the API as well. So I'm very like worried about overusing the map API, so I put in stuff like that.
Okay.
Anyway, did that answer your question, Alan?
Yeah, yeah.
So
Okay.
how many job you like how many job you submit, like how many jobs you know like is too many, or do you see what I mean? So how many
So
total
yeah,
is
so
it?
for me, the rule of thumb has become like one continent for 1 year is a good size. It
That's how
could
many job?
in
How
if I
many?
do CONUS for like
Uh,
2020 or
yeah.
something, it'll typically be between 2 and 3,000,
Oh, okay.
and it can handle that just fine.
Okay.
Um, Beyond that, it could probably handle it, but I think you'll probably have a higher failure rate, and it also becomes unwieldy to download because it's it just gets big, and I don't know if it's my internet or like Amazon, but it takes a while to do these downloads. So yeah.
So say you say first time you run 10 jobs, and
Yeah,
because you didn't really finish complete, right? So
right.
second time you resubmit, say another say 1,000 job.
Yeah, so there's right. So if well, look what's happening now in the current run. We already
Oh,
had one failure. This is what I was
yeah.
talking about, where like I think this is like a network thing where if a bunch
Oh,
of stuff submits at once, which I tried
yeah.
to mitigate by having it pause, but still it happens. A bunch of stuff
Yeah.
submits at once. A lot of times you get a failure right up front.
Yeah.
And so here I can pause it and type R, and it resubmitted one job, and now failed is back to 0, and we have that one job went back into submitted. So you can do that like on the fly, and a lot of times
Oh,
that's a much more efficient way to do it than doing another run at the end.
oh,
Um, but if you do need to do another run, then yeah, you can do it. That's when you use redo of, and you give it the tag of the thing you want to redo. But as Alan was asking about, it's less efficient because it's only I mean, I think there's probably a better way to do this, but the way
mm,
that I implemented it, it's only looking for the output files. So
mm.
jobs that succeeded but didn't produce anything will get rerun. So it's I mean those should run pretty quickly because nothing happens, but it's more efficient to do it like in this, and it's also nicer because it's just much less work to do only one run and then only one download and only one, so so this way, if you can get it to work close enough. I mean, it's hard to get it to 100%. A lot of times something will fail stubbornly, but typically you can get it pretty close.
You can also submit the job without the number of limited jobs. Say, I just want to run continent of US for 1 year, right? Is that right? Without this,
The
like,
limit, I made it
yeah.
so that you have to provide a limit But you should just provide a limit that's high enough that it'll get everything. Because I just want to put a ceiling on how much you're asking MAAP to do, and I want to force the user to do that.
Okay.
Yeah.
Okay. So you needed to kind of have a sense like say Francesca running Columbia, she needed
Yeah.
to have a sense like how many jobs there,
Yeah.
right?
I would say so. I typically, for big runs, I typically use 3,000. I've never exceeded 3,000.
Oh,
And if you are exceeding 3,000, I might suggest breaking it up into smaller time frames. Yeah.
I see. I see.
Yeah.
Um,
I mean, I haven't pushed it. Like, you could probably push it a little further, but I just find that when I'm doing those big, like around 3,000 runs, it's for my processing pipeline that I wouldn't really want to go a lot bigger than that.
can I ask a question about the inputs again, just to clear
Yes.
something up? I should have asked in the beginning, but I
No
assumed
worries.
I assumed the TIFF files were like the boundaries, but you mentioned you could have a larger TIFF.
Yeah.
Uh,
So
and then the input. Where's the input specification for the boundary? Is it it's a shapefile that you put into the configuration?
it's a
folder?
shapefile or a geo package.
Okay.
It should be a polygon or a multi-polygon, and it should have one layer,
Okay. So
and go ahead.
It's in the -B conus.geopackage, and that's
Yeah.
what you're specifying. Okay. All right.
Yes.
I got it.
Yep. And yeah. Yeah, oh yeah, and it should be in like WGS 84, like 4326. But other than that,
So lat long, basically.
yeah.
Okay.
Sorry. So that long?
Well, I mean, in practice, you just transform it to EPSG 4326, which is kind of standard. And I mean, I could write it so that maybe I did make it reproject it. I'm not sure. I think I at least put like a error catch for it. I forget if I put in reprojection,
Yeah.
but just use 4326.
But your TIFF file is
Same.
a RAS. Yeah, it's RAS.
Still has a projection. Also should be 4326. Yeah.
Oh, okay, yeah. Okay.
Yep. Yep. Okay, so now, yeah, it's interesting to watch these progress. I made it so that it should be pretty much just left to right. So this you see we have this one still just stuck in submitted. That's presumably the one that we resubmitted. And now we're running 136 at a time. And this it depends. It depends a lot on like time of day, and it's unpredictable how quickly it will go and how many it will do at once. I don't really know any rules. Another thing to be aware of is that lately the NASA query tool that is what's happening up here when it's figuring out what granules. Oh, we have a success. When it's figuring out what granules, that has been a little unstable lately. So you'll get an error message that explains that. If that's the reason why this fails, it'll say like couldn't get collection ID or like something like that. But something to be aware of. It keeps getting overloaded at like exactly 8 p.m. So I think someone might be running some huge query at 8 p.m. every day. But, yeah. And sometimes MAAP it will just reject or fail a lot of your jobs because Amazon is being stingy and like there's no way to know. It hasn't been a huge issue for me, but it is a thing.
Okay. That's good.
Okay, should I talk about the downloading part?
Sure. Yeah.
Sure.
Okay, so this part is a bit complicated because the naive thing to do, which is what I did, is just literally download it. Like you can navigate to the output of these, click on it, and like click download, and it would download to your computer. But as I was explaining earlier, that will put a lot of load on the shared ADE cluster. And especially for these big jobs where the outputs are going to be, at least tens of gigabytes, if not more, then it can really clog things for other users of MAP. I mean, specifically, like it's a network traffic issue. So people will start actually having their workspaces like freeze or crash because the workspaces themselves are using those same network resources. So the way to do it instead is to use the AWS tools, as I was explaining it, and this is all explained in this user guide down in retrieve results. Yeah, so the first thing you have to do is you have to have the credentials to access the map bucket from your computer in order to do this via S3. And there should be a better way to do this, but the kind of like workaround that they pointed me towards, the map admins and developers, was there's a facility for getting temporary credentials that will last maybe an hour from map. So I have this little tiny script, which is also in the guide. All this does is it initiates one of these map objects, and it gets the temporary credentials, and it writes them to a JSON file in your map folder. Really, I guess wherever you run this from. So you do that. Then I have a script here, download from workspace. This you can run from your own computer, and you need to give it those temporary credentials. The way that I do that is I just go to the temporary credentials. So if I run this, it's going to update. Where is it? Oh yeah, here. Temp credentials.json. You don't ever need to look at this, but like running this will just update this file, or like create it or overwrite it with valid credentials. Now you can press this. You can get copy download link, and this download link is like not authenticated. Like you can just from your computer with no authentication, you can just like download the file using this link, which means that what I do is I use that link, I save it in credentials URL in the terminal, and then the download from workspace script needs the credentials as a JSON, but you can just curl it into the argument using this little command substitution. I forget which is which. This kind of substitution in Bash, and then that'll work. So then you give it the output directory where you want it to all download into, and you need to tell it, again, the algorithm name and the biomass index, again, the name and the tag. You need to tell it all of this stuff because this is how it finds the correct output directory. So you'll run this. By default, the processing tool writes its output in a compressed form so that this downloading process is a lot faster than it otherwise would be. So when you do this, you're going to get on your computer, let me see if I can find 1 second. Give me just 1 second. I will find an example. Right. Okay. So what this will give you is, let me just switch over the share really quick. It's going to give you a directory like this, where you end up, this is the output directory that I told it to write into. Wait, why am I a dark background now? I did not mean to do that. This is whatever you told it to write into. So now you get this big like hierarchy, which is very deep. These are all like timestamps essentially. And at the bottom of every like directory chain, you'll end up with a geo package. However, when you download it, it won't be a geo package. It'll be a compressed geo package. So it'll be like .geopackage.bz2. And there are instructions in here for how to decompress those all in place. If you can, I definitely recommend doing it in parallel, whatever your preferred way of doing that is, but it can be slow if you just try to do it sequentially for a big run. But it's worth it because it makes the download is really the bottleneck, and this makes the download, I don't know, probably a third or half it as the time that it would be otherwise. So anyway, so you do that, and then you end up with this big directory structure of geo packages. And what you do from there is up to you. So, you could here, this is like a gdal command that will merge it all into one big geo package if you want to do that. You might have some other goal that works better parallelizing on the smaller files, which is, for example, the FIA hexagons that I showed you. But yeah, that point is kind of, at that point it is your decision. Yeah. Any questions about that? It's a little bit roundabout, but that's the best way I've found to do it.
Say you have like 100 gigabytes. Do you need to make sure the amount you download is within the 1 hour window of the credentials, or?
Well, you shouldn't. I forget exactly how I implemented the AWS script, but AWS definitely has a facility for syncing rather than copying, so that you could like you could resume. Let me just double check what I did. Wait, which am I sharing right now?
You're sharing your computer screen.
Oh yeah, so like the code?
Yeah.
Okay, yeah. So it's using sync. So yeah, you should be good. You shouldn't need to worry about that.
Okay.
Yeah.
Do you mind if I ask about the MAAP storage policies as well?
Sure, yeah.
How much of the S3 bucket can you take up? Is it like a communal one for?
I don't think they're worried about that.
Okay.
I think they're worried about like network resources and like memory and CPU of the shared, but like of the ADE shared environment. But I think it's designed, the explicit purpose of MAAP is to support like extremely data intensive NASA projects. So I think for our purposes, the S3 bucket space should be unlimited.
Mhm.
I've
Okay.
never gotten in trouble over that, I'll say. So.
Okay, great.
Suggestion for your GitHub site. I think for your README file, you should
Yeah.
put the reference. You put our 2022 paper and also your paper.
Yeah, okay. I should do that.
Yeah, and also we're submitting the other one. So if you submit it, yeah, you could also put it.
That's true. Yeah. Yeah, I think that's pretty much all I wanted to cover. Oh yeah, I guess I kind of already showed you all the QGIS stuff. So yeah, no, that's pretty much it. I mean, I think in practice, if somebody wants to use this for something, then you'll still probably need to ask me. Something will come up, and that's fine, and you can definitely ask me. I think the guide should be pretty exhaustive, but it might, there might be something wrong or incomplete or whatever. And MAAP itself is a bit confusing, so. Or not just confusing, but also a little unreliable. Sometimes sometimes MAAP itself will break. So.
at least I have kind of general understanding what you've been doing.
This whole time, yeah. It's like the debrief, like what have you actually done this 2 years? Yeah. Yeah.
Okay.
Yeah, I mean, I think it works, you know. I've been doing big CONUS runs pretty painlessly
Gosh,
this week
it's
on
not,
it. What's that?
it's not recording. Oh,
Oh, that's too bad.
It says it's recording though on the
oh,
top.
it's recording.
Oh,
Okay.
okay.
Okay. That sounds good. Okay.
Yeah.
Okay, so I have a question. Yeah, not re related, but not directly. Is this part about this? You said you could make something waveform visualization of the waveform stuff. So related to this part, or has to be separated package or something?
Um, well, what I made was a tool to visualize waveforms when you have files locally. So you can do that. It uses the same backend, you know, I mean, what it actually does is it runs, like you select some shot number, really quickly
Yeah.
it runs the model on just that waveform, and then it shows you the plot. But integrating it with MAAP, or, you know, making it,
Yeah.
specifically
No.
making it so that you can run it without already having the files takes a bit more work.
Okay. So you already have this one like on the first server to to look at the waveform? Because I
Yeah,
want
well,
to see
it's in
whether
the same repository, yeah.
yeah, I want to see whether Alex could kind of pick up something quick because I'm finalize this Gabon paper, and
Uh,
I
well,
feel like
Alex definitely has his own way of making those plots. But yeah, I don't know. I guess depends on what you want to do.
okay. Okay, so in general, I think this is what you show about the model, right? I think I have more specific question for you and Alex um, about this Gabon paper stuff so that we can complete it.
Oh
So, I
yeah.
mean, yeah. So, I mean, yeah. So, Francesca and Alan, if you don't want to stay, you're welcome to stay. If you don't want to stay, you don't need to. Um, or more like a more specialist task.
Okay, well, thanks Ian for the demo. I definitely will be contacting you. But yeah, I think overall this was really helpful and I'll
Yeah.
take a peek at the GitHub and try to download something like small.
Yeah. Yeah, yeah. Definitely let me know. It's really hard to, you know, it really would probably take more time. It's hard to like you know, brain dump all of that in like an hour and a half or whatever. But yeah, totally. Let me know what your questions are.